Hello, everyone, and welcome. We're going to be looking at practicing with interior angles of polygons today. So a simple definition when we start talking about polygons is that a polygon is a closed figure that is made up of at least a minimum of 3 line segments. And those line segments need to connect from end to end in order to make it that closed figure. We can also look at the word polygon, and that is a combination of 2 words. So poly is going to mean many, and then gon is going to mean side. So polygons can tell you that there are many sides. Looking at this chart, these are all going to be different forms of polygons. So polygon can be classified as a triangle, quadrilateral, pentagon. Okay, and how we determine how it's going to be classified is we look at the sides. So a triangle has 3 sides. A quadrilateral has 4 sides. Pentagon has 5 sides. A hexagon has 6 sides. A heptagon has 7 sides. An octagon has 8 sides. A nonagon has 9 sides. A decagon has 10 sides. And then a dodecagon is going to have 12 sides. Okay, so when you're looking at these shapes, you can count the number of sides, and that's going to tell you what this is going to be classified as. I would encourage you to take a screenshot of this chart. This is going to be very helpful. I know we used it for some other help videos as well. It will be something that we're going to see pretty regularly throughout this unit in pre-algebra. So looking at this first example, we're going to look at a couple of examples. So one thing to keep in mind is, and to remember, that the measure of the angles of a triangle are going to all add up to 180 degrees, okay? If it's a triangle, it's going to have 3 angles, and all of those angles will add up to be 180 degrees, okay? So in order to figure out the angle measures of a polygon, it's important to look at how many triangles can you use to make up that shape, or in this case, that quadrilateral. Okay, so what is the sum of the angle measures of this shape? So first thing we're going to do is we're going to look at, okay, we've got 1, 2, 3, 4 sides, and that's how we're going to determine that this is a quadrilateral. There are 4 sides, okay? And then when we want to think about how many triangles make up that quadrilateral, we want to start from one corner or one endpoint, and we want to connect it to another endpoint. Now, if we connected here, this is just the outside line, so that's not going to work. So in this case, we are going to connect it right here to this endpoint, and this is going to create our middle line that's also going to tell us that we have 2 separate triangles in this quadrilateral. Each of these triangles, their angle measures are going to add up to equal 180 degrees. So this triangle, these 3 angles will add to be 180. And then this one over here is also going to add to 180 with these 3 angle measures. So after we've determined this, we can say that since there's 2 triangles, we can multiply that by 180, and then we learn that this quadrilateral is going to be add up, all of the angles will add up to be 360 degrees. Moving on to the next one. Next question, I'll clear this out. So now we have this figure here that we want to determine. And so we're going to count the amount of sides. We've got 1, 2, 3, 4, 5, 6 sides for the shape. Now, looking at this, and then if we go back to this chart here, a hexagon has 6 sides, but it doesn't, the shape that we have on our example doesn't look like this, and that's okay. It still has those 6 sides that we're working with. So after we've determined that it's a hexagon, we want to go ahead and from one endpoint. Now, if we draw here, that would just be the exterior line. And so we're going to draw it to this point here. That's going to give us one triangle here that adds up to 180 degrees, the angle measures. And then we draw one here. This is going to add up to 180 degrees. And an endpoint here. And this is going to give us 2 more triangles that add up to be 180 degrees, which means that this hexagon is made up of 4 separate triangles. And each of those have angle measures that add to 180 degrees. So we would have 4 times 180, and this would show us that this hexagon is going to add up to be 720 degrees total. Looking at another example here. First thing we want to do is we want to count the sides. So we've got 1, 2, 3, 4, 5. There are 5 sides to this shape, which means this is going to be a pentagon, okay? Again, it doesn't have to look like our ordinary pentagon from that chart that we have, but the amount of sides is going to tell us what this is going to be classified as. So we start at a point here. We want to draw it to this part here. This is going to show us this, and this triangle is going to be 180 degrees. And then we have another one here, which is going to give us 2 more triangles that are going to be 180 degrees each. Okay, the angle measures are going to add up to 180, which means we have 3 separate triangles here. So we can multiply 3 times 180, and we would get the angle measures of this pentagon are going to add up to be 540 degrees. All right, we'll keep going with these examples. There's going to be a couple different ones that we're going to run into. Again, this one we count our sides 1, 2, 3, 4, 5. Again, this has also got 5 sides, but the thing is it doesn't look like the last one that we worked on. This shape here does not look like the one from our new example here, and that's okay. It has 5 sides. It is classified as a pentagon. So how many triangles can we fit into this pentagon? Okay. We connect our endpoints inside, and this will give us 180 degrees here, 180 degrees here, and then 180 degrees here. So again, it's made up of 3 different triangles. So we multiply 3 times 180, and we get that the angle measures of this pentagon add up to be 540 degrees, which, if you remember, that's what it was for the last example of the pentagon, okay? Even though it does not look the same, you can still fit the same amount of triangles in there, and you have to remember that if you have one triangle, that the angle measures add up to be 180 degrees. There is going to be some questions too where you're not going to have a picture, okay? So if there's no picture, you want to go back to the chart that has the names of the shape with how many sides they have. So this chart from the beginning that I encourage you to take a screenshot of, okay? You can use this. So if it tells you in the description, it says, what is the sum of the angle measures in a heptagon? We could go back to that chart and we can pick out, this is what a heptagon looks like. It has 7 sides, okay? And then we want to figure out, we could draw this and we could put our triangles in there, okay? We want to figure out how many triangles we could get in there. So if we connected, this is a triangle. Okay, so kind of like the picture we have, I know there's a couple smaller triangles, okay? But over here, we could see we've got our endpoint here. We have one triangle here, which is 180 degrees. We have, oh, and these 2 lines, these are just the exterior lines. So we'll use this chart over here. So we connect these points here. This creates a triangle. This endpoint here creates a triangle, 180 degrees again. This one here, 180 degrees. And then we have one more that's going to give us 2 more triangles that are each going to have angle measures that add up to 180 degrees. So this heptagon, 7 sides, is going to be made up of 5 triangles. So we are going to multiply 5 times 180, and that's going to tell us that the angle measures of a heptagon are going to add up to 900 degrees. Now we're going to look at a couple examples that are not similar to what we've been looking at, okay? So this is going to say, and this is where it's important, make sure to read the question carefully. What is the measure of each angle in a regular quadrilateral? Okay, so quadrilateral is going to have 4 sides, 1, 2, 3, 4. We know that this is 4 sides, but we want to know, now we're not looking at the sum of the angles, we're looking at each angle, okay? So again, we want to figure out how many triangles make up a quadrilateral. So we can connect these 2 points, gives us 2 separate triangles, and this is 180, this is 180, okay? And we multiply. 2 times 180 is going to tell us that this quadrilateral is equal to 360 degrees total, okay? 360 degrees total. To find the measure of each angle, this part's very important. To find the measure of each angle, divide 360 by the number of angles. So 360, we've got 1, this is 2. Actually, I'll use this part here. We've got 1 angle here, 2 angles here, 3 angles here, and then 4 angles total. We're going to divide 360 by 4, or you could write it like this here, and that's going to give us an answer of 360 divided by 4 is going to give us 90. So that means each angle in a regular quadrilateral, so that means all of the angles are the same, that's going to tell us that each angle measures 90 degrees, okay? If it says regular, if it's asking you how much each angle is equal, they're probably going to be equal to the same amount. And then the last example we're going to look at is, again, similar to the last one. What is the measure of each angle in a regular polygon, 6 sides, okay? So if we refer back to our chart, we can see that 6 sides is going to be a hexagon right here, okay? 6 sides is a hexagon, okay? Find out how many triangles make up a polygon with 6 sides. So again, we're going to draw our triangles here. This is going to add up to be 180 degrees. This one is going to add to 180 degrees, 180 degrees here, and the last one is 180 degrees as well. So a polygon with 6 sides is made up of 4 triangles with each of their angle measures of those triangles adding to be 180 per triangle. So we're going to take 4 and multiply by 180. We're going to get a total of 720 degrees. So all of the angles are going to add to 720 degrees. And then again, this part is very important down here. To find the measure of each angle, we're going to divide 720 by the number of angles. So we want to go back to, I'm going to go back to the original one. And I've got 1 angle here, 2, 3, 4, 5, and then 6. So I have 6 angles total. So 6 sides, 6 angles. And I'm going to divide 720 by 6. You can set it up like this way, or you can also set it up like this. But either way, 720 divided by 6 is going to give you a total of 120 degrees, which means that each angle in a regular polygon with 6 sides will measure 120 degrees. All right, I'm going to go back to the charts. That way, if you need to, you can pause this and save this. Now that you can see we're going to use this quite a bit, especially with this activity, I would encourage you to save this so that you can use this for similar questions.